Assalamu alaikum dear students. Welcome to these video lectures. This is the subject of communication system. I hope all of you might have the syllabus copy with you. Let's start with the unit 1, evolution and benefits of communication technology. Early days, the mode of communication was use of beating drums, trained pigeons. Drum beating was used for short distance while trained pigeons were used for long distances. Between 13th and 16th century, dark system was introduced. Dark system was introduced by few rulers, wherein the few messages were collected from far ends of the kingdom and were placed in the dark chowkis located at few specific points. Later on, those messages were carried to the capital system, and again the vice versa system was followed. During 19th century, postal system was introduced. During 20th century, first TV transmission was made by BBC. Besides fax, fiber optics and World Wide Web was also invented. However, with the advent of technology, more and more facilities came into existence like email, video phones, satellite communication, etc. Introduction of this communication technology. Communication means to convey some message or information from one person to another person or from one place to another place, and hence the technology that is involved in performing this communication effectively is known as communication technology. The benefits of communication technology will be discussed in the coming slides or the coming lectures in detail. Moving forward, next in your syllabus comes the classification of signals. But before moving on to the classification of signals, let us see the definition of a signal. A function of one or more independent variables that contains some information is known as signal. In electrical sense, voltage and current are also signals. Signals are broadly classified as continuous time and discrete time signals, periodic and non-periodic signals, deterministic and non-deterministic signals, even and odd signals, energy and power signals, analog and digital signals. Now, classification of signals. In your syllabus, only there are two types of signals. One is deterministic and non-deterministic. The second is even and odd signals. Those classifications which are in green color are in your syllabus. The rest of the four are not. So let us discuss them one by one. Deterministic signals are those signals which can be completely specified in time. The pattern of these type of signals is regular and hence can be expressed mathematically. In addition to this, the nature and amplitude of such a signal at any time can be predicted. For example, a ramp signal whose amplitude increases linearly with time and the slope is equal to the value or the constant that is given. Another example of the deterministic signal is your sinusoidal signal, whose future values and future amplitude or the future signal representation can be predicted. Now, non-deterministic or random signals. A random signal is one whose occurrence is always random in nature. The pattern of such signals is quite irregular and cannot be predicted. One simple example of non-deterministic signal is noise. Noise is unpredictable in nature, such as the noise in your environment, the thermal noise that is generated in a circuit. Now, neither amplitude nor nature can be predicted. Second classification of signals in your syllabus is even and odd signals. An even signal may be defined as that type of signal which exhibits symmetry in the time domain. This type of signal is identical about origin. A few examples of these even signals are x square, x raised to power 4, mod x, cos hyperbolic x. All these are examples of even signals. Odd signal is that signal which does not exhibit symmetry in the time domain. It is not identical about the origin. Few examples of odd signals are x raised to power 1, x raised to power 3, sin x, cos hyperbolic x, and so on. Now next is a signal spectrum. Signal spectrum means representing a signal or a wave in its corresponding frequency domain. Signal spectrum includes Fourier series and Fourier transform. Sorry, it is instead of spectrum, it is Fourier transform. Fourier series is used to obtain the frequency spectrum of a time domain signal when the signal is periodic in nature. If you have a periodic signal, you apply Fourier series. If you have a periodic signal, you apply Fourier transform. Again, it is transform here, not spectrum. Now, in your syllabus, the next point is Fourier series analysis of a periodic signal. You have studied these Fourier signals or the Fourier series in your mathematics, so it will not be a difficult thing for you people to learn all these things. It is simple analysis of a periodic signal using Fourier series. A periodic function x of t may be expressed in form of trigonometric Fourier series comprising of sine and cos terms mathematically. X of t equal to a0 plus a1 cos omega naught t plus a2 cos 2 omega naught t plus a3 cos 3 omega naught 3 plus so on up to an cos n omega naught t plus b1 sin omega naught t plus b2 sin 2 omega naught t plus so on up to bn sin n omega naught t. This equation can be rewritten as a0 plus summation n equal to 1 to n to infinity an cos n omega naught t plus bn sin n omega naught t, where capital T is equal to 2 pi by omega naught. An and bn are coefficients, omega naught is fundamental frequency, and 2 omega naught and 3 omega naught, 4 omega naught are the harmonics of omega naught. Now a is the constant and corresponding to n equal to 0. It is expressed by the following equation: a0 equal to 1 by t integration from t0 to t0 plus t x of t dt. From this equation, it's clear that a0 is average value or the DC component of x of t. Also, an is given by an equal to 2 by t integration of t0 to t0 plus t x of t cos n omega naught t dt. And your bn is given by 2 by t integration from t0 to t0 plus t x of t sin n omega naught t dt. Now if we substitute t0 equal to 0, we have an equal to 2 by t integration from 0 to t x of t cos n omega naught t dt, and your bn will become 2 by t integration from 0 to t0 x of t sin n omega naught t dt. Fourier transform. It is applicable for aperiodic signals. Let x of t be any aperiodic signal, then Fourier transform is given by integration from minus infinity to plus infinity x of t e raised power minus j omega t dt. The next point in your syllabus is modulation. Modulation may be defined as the process by which some characteristics or properties or parameters of a signal known as carrier signal is varied according to instantaneous value of another signal known as message signal or modulating signal. The signal which is obtained from the process of modulation is called modulated signal. Now, types of modulation. Modulation can be classified on various parameters, but here we will classify based on the nature of carrier signal. Number one is continuous wave modulation. If the carrier signal is continuous in nature, then the resulting modulation is known as continuous wave modulation. For example, amplitude modulation, angle modulation. Second type of modulation is pulse wave modulation. If the carrier is in the form of pulses, then the resulting modulation is called pulse wave modulation. Few examples of this pulse wave modulation are PPM, that is pulse position modulation, PAM pulse amplitude modulation, PWM pulse width modulation. All these types will be discussed in your unit 4. Now the question arises, why the need of modulation? What is the need of modulation? Why we require the modulation? Modulation serves a number of purposes in the communication. Some of them are listed as under. Number one is practicality of antenna. For efficient radiation and reception of signals, that is for efficient transmission and reception, the antennas, that is transmitting antenna and the receiving antenna, must have lengths equal to quarter wavelength of the frequency used. Mathematically, this statement can be rewritten as L equal to lambda by 4, where L is the length of antenna and lambda is the wavelength that is used, and it is equal to 1/4 of lambda that is being used. This equation can further be rewritten in terms of frequency and velocity of light, that is L equal to c by 4f, where L is length, c is velocity of light, f is the frequency used. Second point, to remove interference. Interference means mixing of several signals when different message signals are being received by the receiver. Interference occurs. The simple definition for interference means mixing of several signals. Now a receiver can receive different message signals 2, 3, 4, 10, 20, 100. A number of these message signals are being received by a single receiver. Obviously the interference will occur. This problem of interference can be eliminated by making use of the modulation. Number third is reduction of noise. Noise is a major problem in every communication system. This noise cannot be eliminated completely, that is 100% elimination of noise is not possible, but can be decreased to a greater extent by using different modulation techniques. Those are also in Unit 4. The fourth point is modulation increases the range of communication. Fifth point is modulation increases the quality of reception of signals. Sixth point is multiplexing is possible by making use of modulation. Now we have to study amplitude modulation. AM is defined as the process in which amplitude of the carrier signal is varied according to the amplitude of message signal. Let us consider a carrier signal C of t, which is given by C of t equal to A cos omega ct, where A and omega c are the amplitude and carrier frequency of the carrier signal. Let the message signal be represented by x of t. Then after the process of modulation, the resulting signal is given by SAM of t. So your SAM of t can be written as x of t cos omega ct plus A cos omega ct. Taking cos omega ct common, we have x of t plus A into cos omega ct. Here you can see that amplitude A is being varied according to the message signal x of t, and this whatever lies in the bracket is known as envelope of AM. It is denoted by E of t. Graphically the amplitude modulation is shown in the next slide. Here in this figure we have x of t, this is the message signal, this is our carrier signal. So before modulation these two are independent signals, but after modulation the resulting signal is like this, and we call it the AM signal. Next point is AM modulation index. In AM systems, modulation index may be defined as measure of extent of amplitude variations about an unmodulated maximum carrier. It is denoted by MA. Mathematically, modulation index is equal to the ratio of maximum amplitude of message signal to maximum amplitude of carrier signal. Modulation index is also known as depth of modulation or degree of modulation or modulation factor. If modulation index is multiplied by 100, it is called percentage modulation. Now cases of modulation. Case 1 is under modulation. When the modulation index is less than unity, it is known as under modulation. Here the maximum amplitude of the message signal is less than the maximum amplitude of carrier signal. Critical modulation. When the modulation index is equal to unity, that is 1. Here the maximum amplitude of the message signal is equal to maximum amplitude of the carrier signal. Third case is over modulation. When the modulation index is greater than the unity, here maximum amplitude of the message signal is greater than the maximum amplitude of carrier signal. Bandwidth of AM signal. It is defined as the difference between highest frequency component and lowest frequency component. Mathematically, bandwidth is equal to omega c plus omega m minus omega c minus omega m. This is the highest frequency component when carrier frequency and message frequency are being added, and this is the lowest frequency component. The overall difference is 2 times omega m, or you can say 2 times frequency of message signal. So this is the end of lecture 1. Any queries you can contact. Thank you.